Okay, we've been talking about similarity and writing proportions, and if figures are similar, then it means that their corresponding angles are congruent and their corresponding sides are proportional. So now we're going to take all that we've learned so far and focus it in on triangles. So far you've already learned that if the angles are congruent and the sides are proportional, then they're similar. So just like with congruent triangles, this is the long way to prove that the similar triangles are similar, but there's actually 3 simpler methods. So remember with congruent triangles, there were 5 shortcuts. With similar triangles, there are 3. So grab a highlighter, and if you need a highlighter, go to the red cabinet, and there should be some in there. Just make sure you put it back. And I want you to highlight right here where it says angle, angle, similarity. Now there's your little squiggle, that means similar, so AA, similarity. Here's the deal. If you have 2 angles of a triangle that are the same as 2 angles of another triangle, then that's enough information to prove that the triangles are similar. Look down here at these 2 examples. You see in this triangle I have a 50-degree angle and a 90-degree angle. Well, since the triangle is 180 degrees, add the 50 and the 90, so you get 140. Subtract that from 180, and that means this leftover angle right there has to be 40 degrees. So write your 40 degrees in. So when you look at this small triangle to the big triangle, they each have a 40-degree angle, and they each have a right angle. So we've got 2 angles of this triangle are the same as 2 angles of that triangle. So that's angle, angle. Similarity. And you put a little squiggle to clarify that you're talking about similarity and not congruence. When you look at this second picture, do you see these arrows? Remember I taught you guys that the arrows, and sometimes they can be triangles, those mean that the lines are parallel. Well, when lines are parallel, I taught you guys that you need to look for angles that are the same. So if I have these 2 lines that are parallel, look at this angle and that angle. What kind of angles are those? Those are corresponding angles. And if the lines are parallel, that means the corresponding angles are congruent. So you could get congruent angles from here. You could also do the 2 angles right here, this one and this one. So that would honestly be enough for you to show that the 2 triangles are similar because of angle, angle. But I want to show you something different on this one. In this picture, you're going to see this picture a lot in this unit, so I want to make sure you understand what it's showing. You have a small triangle right here. You'll see the pink triangle, and then you have the big triangle, the orange one. So you have this small triangle comparing to the big triangle. Now when you look at this, what do the small triangle, the pink one, here I'm just going to color it in to help you guys see it better. What do this pink triangle and the orange triangle have in common? They both share point G. Do y'all see that? Now, when we did congruent triangles, we talked about the reflexive property. And reflexive property was when 2 triangles were glued together and they shared that side right there, and so that side was congruent to itself. Well, you can do reflexive property with similar triangles also. Right here, angle G. Angle G in the small triangle is the same as angle G in the big triangle. So angle G is congruent to angle G. That's reflexive property. So you can use reflexive property with angles, but when you do, it's in similar triangles. You won't use reflexive property with angles in congruent triangles. So you're saying the angle G of the pink triangle, the small one, is the same angle as angle G of the big triangle, and that's reflexive property. So you've got 2 angles in the pink triangle that are the same as this angle and that angle in the big triangle. There's angle, angle. Or you could say these corresponding angles and those corresponding angles give you angle, angle similarity. So either way, you can find 2 angles of the small triangle that are the same as 2 angles of the big triangle. And so these are similar, okay? The next way, so that's the first way, angle, angle. 2 angles, you know they're similar, you're done. The next way is called side, side, side similarity. Side, side, side is when you have a triangle like this, where you've got 3 different sets of side lengths? Well, sometimes the triangles are facing the same way and you can tell which sides are corresponding, but most of the time, like in this picture, they're going to be flipped. And you have to figure out, okay, does the 16 go with the 20, the 15, or the 10? Here's how you figure it out, and it's very easy, so just make sure you do this each time. When you're figuring out which sides go together, you're going to put your small sides together, your medium sides together, and your large sides together. So when I look at this triangle, 16, 24, 32, which of these is my smallest side? The 16. So you're going to put an S by 16 for small. Which of these sides is my medium side? The 24. So put an M by 24. And then your 32 is your largest side. Okay, go do the same thing in the small triangle. Which of these is my smallest side? The 15. So put an S right there. Oops, I'm sorry, that's wrong. The 10 is the smallest. The 15 is the medium. And which one is the large? The 20. Okay, so when I'm matching up corresponding sides, the small from this triangle is the same, goes with the small from this triangle. So 10 goes with 16. So you're going to write a fraction, 10 over 16. And then you simplify it, and this is the scale factor. So that's 10 over 16 reduces to 5 over 8. So that's your scale factor. If all of these have the same scale factor, then it's similar by side, side, side. So you match up your mediums, 15 and 24. You write your fraction, it reduces to 5 over 8. And like I said in the other video, if you're not sure how to reduce fractions on your calculator, just come bring it to me and I'll show you. It's real easy. But it's different based on which calculator you have. Okay, and then you have your large, 20 and 32. 20 and 32, it reduces to 5 over 8. So do you see how each of these scale factors is the same? Then that means these two triangles are similar because all 3 sides are proportional. Now you cannot just do 2 and say, oh, well 2 sides are the same, so it must be similar. It's not SS similarity, it's SSS. So you have to do all 3, and these are similar by side, side, side similarity. And always draw that squiggle at the end to show you're talking about similarity. Okay? Now flip this over on the back, and we'll get to our last shortcut, which is SAS, side, angle, side. Now remember when I talked about congruent triangles and we said, okay, if it's side, angle, side, angle, side, your angle is going to be sandwiched in between your 2 sides. Same thing has to happen here, okay? So when you're looking at this picture, you have to figure out which sides go together. On this one, you can do the small and medium deal again, like your 6 is smaller than 9, 8 smaller than 12, so the 6 and the 8 are going to go together, and then the 12 and the 9 are going to go together. But let me point something out real quick. Do you see right here on this fraction where they do 12 over 9? So they're going from big triangle to small triangle, and they reduce that and get the scale factor 4/3. If you're writing your scale factor, if you're trying to see if these triangles are similar, and you write 12 over 9, you have to do the same pattern on the other side. So if I put 12 over 9, I can't go from 6 to 8. I can't do big to small equals small to big. I have to keep it the same. So I'm going to put 12 over 9, big to small, equals 8 over 6, big to small. So that's what they're doing here, 8 over 6, and when you reduce that, you get 4/3. So far I have 2 scale factors that are the same. Well, that's only 2 scale factors. I would need 3 to do side, side, side. But do y'all see right here, this X? What are you supposed to look for when you have an X? You look for vertical angles. So there are your vertical angles. And so now, since I have these scale factors are the same as those scale factor, then I've got side, angle, side. And again, your angle has to be sandwiched between the 2 sides or it won't work. So this is side, angle, side, similarity. And you put your little squiggle, okay? Now, here's what I want you to do. I want you to look at these 3 problems here, decide if they're similar or not. If they are similar, then write out the reason. So you would say, They're similar by angle, angle. So here's our three we've got. We've got angle, angle similarity, side, side, side similarity, and side, angle, side similarity. If it's not one of these three, then the answer is none. There's not enough information. So hit pause real quick and see if you can do these three problems. Okay, so you should have hit pause and you should have done these three problems. So now we're going to check. When you look at this triangle, do you see that there is this small triangle here, and then you have the bigger triangle there? Okay. Right here you've got 130. What's true about 130 and this angle right there? Those are a linear pair. So if that's 130, this angle is 50, because 130 and 50 add up to 180. So do you see right here I have a 50-degree angle and a 50-degree angle? Well, there's one angle that's the same. The 50-degree of the small triangle is the same as the 50-degree in the big triangle. Okay, now I need one more angle for this to be angle, angle. Well, do you see the small triangle has angle A? And the big triangle also has angle A? So angle A of the small triangle is the same as angle A of the big triangle. That's reflexive property, remember? I'm just going to put RP, reflexive property. So I've got the two angles both have 50 degrees, and two triangles both have 50 degrees, and they both have angle A, so they are similar by angle, angle similarity. That's all you put. Okay, look at the second one. I've got 12 and 9, so I can do 12 over 9, which if I divide both of those by 3, I get 4 over 3, okay? And then I look at the 8. Well, the 8 goes with this side, WV. Do y'all see that? And I don't know what this side is, so I don't have enough information to make another scale factor. I do have the vertical angles here are congruent, but I can't do side angle. That's not one of our three ways over here. So in this picture, I don't have enough information. So I'm going to write not enough info. I don't know if they're similar because I don't have enough information. All right, last one. This one, you've got two triangles that are joined together. You've got a whole bunch of side lengths, so you've got to figure out scale factors. To figure out which sides go together, you're going to do small, medium, large. So looking at just this triangle right here, 16, 20, and 24. Which one's the small? 16. The medium, 20. And the large, 24. Okay? So you're going to set up your scale factors, small, medium, large. I'm going to put 16 over something, 20 over something, 24 over something. And we're going to figure out what these other numbers are. Look at this big triangle. You have 24, 30, and 36. Out of those, which one's the smallest? The 24. So your 24 is serving double duty. It's the largest side in this triangle, and it's the smallest side in this triangle. That's okay. So the 24 is the smallest. I'm going to pair it with the 16. The 30 is a medium. I'm going to pair it with the 20. The 36 is the large. I'm going to pair it with the 24. Oops, 36. Then reduce each of these. When you reduce them, each of these gives you 2/3. So that makes it similar by side, side, side similarity. Okay? There's a second video because I'm going to work with some of the problems in the worksheet with you guys, but you'll watch part B in just a minute.